I never would have believed we would have been in a college level class, and I am going to teach you the definition of a rock. Okay, oops, okay. So, what in the world is a rock? All right? A rock. I mean, this seems so basic an idea that you would think that you wouldn't even have to define this, but a rock is a solid substance that occurs naturally because of the effects of three processes. Okay, we're going to have magma that becomes solid, or we're going to have a sedimentation of other rocks, or we're going to have a metamorphic effect, and it's going to change a rock. And the fact that rocks are composed of minerals, they're mixtures. Okay? Now, that seems so basic. And I bet you could probably, if I showed you a rock, you could tell me what a rock was, right? All right. You guys are ready, right? Okay. Okay. See them? Okay. I've got two samples right here. Okay. See that? Yeah. Okay. Want everybody to take a look? The question is, how many rocks do I have in my hand? What'd you say? You said one. Come now. How many rocks do I have in my hand? Ah, could be zero. Okay. They both look like a rock, don't they? I mean, feels like a rock. Oh, shoot. Feels like a rock. Okay. If I threw it at you, it would feel like a rock. Okay. But in actuality, I have one rock in my hand. Okay. What? Okay. Would you believe that? Okay. Would a 3-year-old believe me? Or a third grader? No, they would say I'm lying. Because I obviously have two rocks in my hands. Okay? But this one right here, this darker one, is a rock. This one right here is not a rock, although it has the same shape. It looks like a chunk of rock. It is actually classified something different. Okay? Rocks are composed of a mixture of minerals. Okay? So what is a mineral? Well, when we made ionic compounds like sodium and chloride, the sodium and chloride is an ionic compound, but if you find sodium chloride in nature and you pick it up as a chunk, we call that halite, the mineral halite. A mineral is an ionic compound, and all you have in that would be, in the halite's case, only sodium and chloride. Just sodium chloride all over. Okay? This is a mineral. There is only one kind of compound in here, and it's fully that one compound. Okay? And so it is not a rock because it's not a mixture. A rock, on the other hand, you can see little flakes and pieces. There are multiple kinds of minerals that are mixed up all together that are solid, and that is what a rock is. And so sometimes you look at something and you might think it's a rock, and it could in actuality be a pure mineral. And so sometimes we can't tell by just looking. All right? And that's kind of weird because you wouldn't have expected that particularly. Okay. Minerals are inorganic solids that have a crystalline structure and distinct chemical composition. We talked about it in chemistry, and a lot of this is what happens in science a lot of times. One type of scientist will call it one thing, and a whole other type of scientist will call it another thing, but they're actually the same thing. And so a mineral is an ionic compound, okay? And a chemist calls it an ionic compound. A geologist will call it a mineral. But it has a distinct chemical composition because it's a distinct chemical. Now, if I take a look at the crust of the Earth, which is mainly composed of rock, these are the elements that we see in the crust. And so the two bigwies are what on that list? Oxygen and silicon. Okay? And that will make up, the combination of oxygen and silicon is a component of almost every mineral and every rock that you are going to encounter. But then you have other stuff like aluminum and iron, calcium, sodium, potassium, magnesium, all those metals, and they will create new compounds. And then the rest of the periodic table is in that tiny little sliver. Okay? So there are other elements that are in rocks and minerals, but they're not a large component of those. The two main, silicon and oxygen, that's something that you do need to know. Now, because silicon and oxygen are so important, there are two different ways that silicon and oxygen tend to combine in the Earth's crust. One is silica, silica, which is silicon dioxide, two oxygens and one silicon. And it binds pretty tightly, makes a crystal structure, and we find this material in several types of rocks and one mineral particularly. The most often found is Si-O4 with a 4- charge. It's called silicate. It is an anion. And so if I went back to the first chapter, and really this is why we talked about some chemistry, if by chance I reacted with sodium, you would predict that it is a +1 because you know that or you looked it up on the chart. And then you would have silicon, the silicate that's a -4. A +1 and a -4, a +1 and a -4 don't balance out each other. So I would write the compound sodium 4 SiO4 as the mineral. Okay? And that can happen. But with the silicate that has a -4 charge, you could also find this. A sodium with a +1, a potassium with a +1, a magnesium with a +2, and a silicate with a 4-. The silicate has 4 minuses. And all the pluses, when you add them all up, is 4 pluses. And so minerals can get a whole lot more complex in terms of the combinations that they can make. And so one sodium, one potassium, and one magnesium bound to that is different than if I had 2 sodiums, 1 magnesium bound to that. And so there's a lot of different combinations that minerals can have. Rocks are heterogeneous solids. And remember, heterogeneous is you can pick out pieces. The example of the rock is a polished rock up there. And so you don't necessarily find a rock that is nice and smooth and shiny. But what you do find is a rock that has flakes in it where you can see different colors and different pieces. Each one of those different colors is a pure mineral. And there's lots of minerals embedded in this rock. Before that was polished, do you see how big the minerals are, those big crystals? If you actually picked it up before it was polished, it would be very, very rough because you would be broken along all of those different fragments because the crystal size is so big. That would be a coarse-grained rock. Sometimes the grains become so little tiny that the rock could feel smooth, and you would take a microscope to actually see the crystal, the little chunks, but they're there even if they're small. When we talk about minerals, They actually have a defined composition. If it's 2 sodiums and 1 magnesium to a silicate, that's defined. And we have over 4,000 minerals to go through to look at these. Now, one thing about minerals, because they're ions, they like to order and line up in regular repeating patterns. You can't see the atoms line up in regular patterns, but if the atom, because they're so small, but if the atoms grow and they fill in the space, what you can see is the crystal structure, which is related to how they pack together. And so a lot of minerals can be classified by the kinds of crystal structures that are formed. If you've ever gone into a rock shop, my girls love to go into the gem stores, especially in Dollywood there's one, and they would walk in and be fascinated and they would see all these crystals. And really the crystals are minerals that have grown over time very slowly to create these wonderful shapes that exist in nature. They're very regular and repeating. Now, sometimes you get a crystal and you can't actually see the structure itself. It actually looks kind of like this, lumpy. But if you've ever seen the cartoon character of a geologist, they're in khaki shorts and a hat, and they've got a hammer with them. If you hit a mineral, or sometimes rocks, you can hit it and it will break, and you will make what are called cleavage planes, flat areas, which are reminiscent and give hints to what the crystal structure really is. And so a lot of times they'll break the minerals and see what kind of relationship are the planes that are made to try to identify what they are. And so that goes back. Now, how many minerals did we have? Over what?
4,000.
Over 4,000, yes.
So each mineral has a different...
Each mineral can be classified into a subset. And so they're not unique enough to be like a fingerprint, but they're unique enough to put it into a certain class and narrow down the field from 4,000 to maybe 20. And so, yeah, you can't do it down to 1. All right, since we have 4,000, it's going to be a long lecture, except for the fact that we're only going to look at 6. Okay? We're going to distill it down to 6 different minerals I want you to know something about. And the minerals we'll look at is quartz, feldspar, mica, a group of minerals called the ferromagnesian minerals, clay minerals, and calcite. Okay? Remember, most of the rock has some silicon and oxygen in it. So most of these minerals will have silicon and oxygen in it. There's one on this chart that doesn't have it, and it's the oddball out, and so that's kind of one you need to know and distinguish from. Quartz is one of those really beautiful ones, and those are the ones that are sold in the gem stores that are perfectly shaped, and if you get a very large one, they're really expensive because it takes a long time to grow in nature, and they're rare. And so a big quartz crystal is usually colored. If it is pure, absolutely clear, like glass. You can see through it. It's transparent. It can also be white. And so this is very pure quartz, which is made up of only the silicon with 2 oxygens, the silicon dioxide. It's a very common mineral that's on the face of the earth, and almost every rock has little chunks of these inside the rocks. If you took this and you put it into a huge blender that could blend up rocks, and you crunch it and you crunch it and you crunch it, what you would end up with is the major component of sand. So sand is little tiny chunks, mainly of quartz. And if you took really purified sand and you heat it up and melt it and allow it to cool, what you get is glass. And so quartz is a very large component of the glass. Now look at this quartz. It's different, right? All right. This is pure quartz, or some people call it milk quartz. This quartz right here is called rose quartz. Okay? It is almost completely all silicon dioxide, but there's a very tiny, and we're talking less than 1%, impurities of another metal in there. It is 99.9% silicon dioxide, and just that hint of something else can produce color. And so it's still a quartz, it just has a little bit of impurities. Feldspar is the most common mineral on the Earth, and there are 20 members in this grouping, but only 9 of them are common. And so what are these made up of? They're the SiO4, the silicates, and what they have attached to them in the front as a cation is calcium, sodium, aluminum, and potassium. Now there are 2 different classes, orthoclase and plagioclase. The reason, or the way that you tell the difference is, orthoclase are the ones that are lighter in color. Plagioclase are the ones that are darker in color. And so the potassium tends to make it light, the sodium and the calcium tends to make it dark. If you take a chunk of it and you hit it with a hammer and it breaks off, you get nice flat edges with blunt ends, and you get cleavage in right angles, in directions at right angles. And so feldspar, the most common mineral in all of Earth is feldspar. Mica is a kind of interesting type of mineral. It's called a phyllosilicate. It has the silicate on it, and it has a white or a lighter color and a black or a darker version. And their silicates, they have the potassium, and last time potassium made the light version, and the magnesium and iron are really what's going to give it the darker version of the mineral. Now, mica is really interesting because you might pick up a piece of mica, and what it is, it's like, they call it sheet-like. Have you ever chopped up an onion? Okay. How are onions organized? They have what? Layers. Well, this rock actually has layers of material, and you can actually peel one layer off, and it's very, very thin. Way back in ancient times, people had used sheets of mica as window material. That thin, and the lighter ones you can actually see through a little bit. Where you might see mica as part of a rock is, does anybody have granite countertops at home? And you shine light, they sparkle a lot of times. The sparkling reflective pieces usually are mica chips in them, little pieces of mica. And that's where you most often might see mica, is in a granite countertop. And so it is a silicate, but instead of making bonds that hold on top and on bottom and on the sides, like most things, these tend to make only connections really in one plane, and then another layer lays down, and there's not much holding the 2 layers together, but there's a lot of strength in the sheets. And so they just bond a little bit differently. The ferromagnesium minerals, this is easy. If you look at it, if you look at a rock, the dark black or the dark green pieces usually fall into this category. The iron and magnesium, and you can see where magnesium minerals come. The ferro comes from the Latin word for iron, where the Fe comes from. That's where we get the ferro. It's got iron, it's got magnesium, and it's bound to silicates. Clay minerals are kind of interesting. It's a little bit different. Really, it is aluminum and silicate together. There's some other stuff mixed in there, like magnesium, iron, or potassium. In particular, there's a picture of clay, and we have a park near us that has a clay in it. What park is it that's near us? Red clay. Red clay. The red comes from just a little bit of iron inside of it. Okay? Clay, the way that the aluminum silicate binds, they contain microcrystals or little tiny crystals. And what they do is, when they pack, they have a lot of space in the middle. And so clays tend to be, if they are dry, if you rub them, they become powdery. But clays, if they are wet, they soak up a lot of water. And they can soak up so much water that clays can be used to mold things and to do ceramics, because that water is in there and you can mold it while it is wet. It still has integrity as it's wet, but it can be molded, and then you dry it out and you fire it out and you fire all of the water out, and it can be used as a clay pot or a cup. You'd have to glaze it to make sure that the water doesn't get back in there, but clays are quite interesting. One thing about clays, though, is that they can soak up a lot of water and then they can create a barrier. Also, when clays actually soak up a lot of water, it can be really hard to dig through. And so if by chance you're going to build a fence around this area, there's a lot of clay in the soil, and so it may be very tough to dig holes around here, and it's because that clay holds together. The last mineral we talk about is calcite. All right. If I give a question like this, this is what I would call the Sesame Street question. Which one is not like the other? Which one is just not the same? Okay. Everything up to this point has silicates and some metals. Calcite, on the other hand, is calcium and carbonate. No silicon at all in it. It is formed from the remnants mainly of shells. And what happens is, when you find a collection of this, you look at it, it looks clear to milky. It looks kind of like quartz, but it will never be mistaken for quartz because the shape is totally different. It kind of makes a rhombic shape, or a square that's kind of tilted over to the side. It is light in color, and it is one of the chief minerals that is in limestone and in marble. Now, marble and limestone tend to be, limestone particularly, tend to be a soft mineral, and both limestone and marble tend to react with water or acids really well, and so they tend to be leached out or broken down. Now, limestone is marble is a conversion of limestone. Marble has a little bit more integrity, but if you ever have marble countertops, it's wonderfully beautiful, and it's really expensive, but it is also a very delicate stone. And so you actually have to treat it a lot more delicately than, let's say, granite. If you put something hot on it, you can break up the stone. In particular, if you spill an acid like vinegar on marble, if it's not treated, meaning a protective coat on it, the vinegar can actually eat away the marble because that chemical reacts with acids, and so you have to take care of the marble for it not to be destroyed by either heat or by spilling things on it. There are three kinds of rocks or types of rocks that there are three ways I can mix all the minerals up together and create a solid rock. Okay, the three types that you need to know are igneous, sedimentary, and metamorphic. Those are the three. The general definition is an igneous rock is a solid rock that was once magma or liquid rock. Okay? If you heat up rock hot enough, it's going to melt and become a liquid. If you go into the center of the earth, all of the rock that is down very, very deep is hot enough to be liquid. And so, as the liquid rock moves towards the surface, it's going to cool down, and as it cools down, it becomes solid. That is igneous rock. Sedimentary rock, on the other hand, is this. There were other rocks at one point in time. We have weathering and erosion that break down rocks, and it breaks down in pieces. And then all of those pieces get collected somewhere, and once those pieces get collected, there can be a transformation, either compacting or other minerals get in there, and it will cement itself together, and I become another rock made of pieces, and that's called sedimentary rock. The last rock, metamorphic rock, is first either igneous rock or it's sedimentary rock first, and then it gets compressed and heated, and this has to happen under the earth, and what happens is you basically cook it, and you cook it in a pressure cooker. The minerals change their associations, and the look and the feel and the organization of the rock changes. It becomes metamorphic, and it becomes a new rock. Okay? And all of these three rocks are interdependent upon themselves. So let's take a look at each of these rocks and talk just a little bit about where they come from and how they are formed. All right? Let's look at the video about igneous.